Now let's have a quick look at some useful built-in commands that can be used on matrices and that will make your life easier when coding. So there will be such functions as size, length, and find. And when we will talk about find, I will also refer to something called logical indexing. So this should have been on this slide as well. All right, so let's start with the size. The size command helps you check how big your matrix is. So of course, if you operate on small ones, you would know, you can easily see it from workspace and so on. But sometimes it's more pleasant or kind of easier to work with when you can ask Matlab and see the size in command window. So that's where the size command comes from, or comes into use. And how it works, you basically, if you have an array, for instance x, you just type size, and then in round parentheses you give the name of the array that you want to check the size. So you can ask for it in two ways. One is that you assign it to one variable, and now depending on what your x is, that's what you will get in here into the D matrix, or into the D resulting variable. So let's jump directly to Matlab and see. We had this example here where we had A and B were two-dimensional and C was three-dimensional. So now let's have a look what comes out. If I say size A without even assigning that result anywhere, then my my resulting answer variable is a vector with two values, 2 and 4, and this will always be in a vector form here, a row vector, where the dimensions are listed one by one. So now it says that in the first dimension it has 2 rows, or 2 layers in the first dimension, second dimension 4 layers. So in this case it's 2 rows, 4 columns. And I could have, let's call it as A, or size of A. I could have assigned it to some variable, so now it's not ans anymore, it's SA. When I do it on B, I will get the same result because B was equally sized. And for instance, if you have a row vector or a column vector, the answer will still come in 2 dimensions. So even though vector is kind of considered one-dimensional, but Matlab will kind of give you the hint or give you the information, is it a row vector or column? This is quite a common mistake when you start operating with vectors and matrices, and you do some calculation and you know that this vector has 100 elements and the other one has 100 elements, but you try to add them up and it doesn't work. So very likely one of them is a row, one is a column, and then the addition will not work. So that's why, for instance, when I ask for size of a vector from 1 to 8, it tells me 1, 8, because it tells me it's 1 row and 8 columns. So it's a row vector. And if I ask a similar thing for a column vector, then it will say it has 6 rows in this case and 1 column, because I have transposed a row vector. It means it's a column now. So that's where function size is very useful when you get an error of saying that the dimensions of maybe matrices trying to be concatenated or matrices trying to be added or multiplied are not consistent. You quickly use this size command and check those matrices that you're trying to operate on. Okay, and now how does it look on the C matrix? Basically the same, but now since C is three-dimensional, I will get 3 pieces of information about it. So now we know that we had A and B combined into 2 layers. So the first 2 dimensions are same size as A and B, but then the third dimension is 2 just because we had 2 layers. So that's one way to get the information out. Another way is that you could actually, for instance, if we talk about matrix A, I want to ask separately how many rows it has and how many columns. And so I ask for the size in this way. So now what will happen is that Matlab knows that this produces 2 values, and I'm pointing to Matlab that I don't want one variable like this SA for size A. I actually want row number and column number separate, as separate variables. So now you see I use square brackets here because I want to combine an array of outputs of my size function. So when I run this piece of code, now row A, so number of rows in A is 2, columns in A is C. So these are 2 separate outputs. So that's what was on the slide here with this second case. So if you ask separately, it returns the size of X in separate variables. What could go wrong when you do it this way? Well, for instance, if I ask size of matrix C, which is 3-dimensional, then now what happens is that Matlab gives you the information of the first dimension correctly, that it's true, but then the other 2 dimensions are now multiplied because it kind of it recognizes that there should have been 3, but now you only asked for 2, so it kind of rearranges in the memory the elements of the matrix to tell you what would be the dimension if you have reshaped your initial C matrix into 2-dimensional matrix. And the other way, if you, for instance, ask for 3 outputs, so row, column, and I'll call it layer A. So now you ask for 3 dimensions from 2-dimensional matrix. Well, naturally, 2-dimensional matrix is like a special case of 3-dimensional one, because it just means it's 1 layer, so we kind of ignore the 3-dimensionality, but it's there. It's just that it's 1 in here. And then you can ask explicitly for just one piece of information. So in here we were asking for both separately, but in here now I can decide, and if I, for instance, say size A1, so this means I'm asking Matlab how many layers are in first dimension of A. First dimension, remember, is rows. This is something you have to get really hold of well. So always first dimension is rows, second dimension is columns. So when I ask for the first dimension, I am asking how many rows are in my matrix. So this should say 2. And when I ask in the same way for second dimension, so now I'm asking how many columns there are, and then it says 4. So here are examples also to what I already did in the code for the 3-dimensional case. Let's jump to the next command, which is length. Now, length, as the definition says, it returns the maximal size. So now how do we understand it? If we talk just about a vector, that means it will just tell us how many elements there are. So if I have vector which has 100 elements, then of course when I asked for length of X, it will say 100. That's all. That's okay. But how about if I actually have, I will now reshape my X into 10 by 5. Oh yeah, should be creating 100. So for instance, 25 by 4, because it has 100 elements, so I need 100 places to fit them in. So now the size of my X, of course, is 25 and 4. If I ask for length of it, it will tell me it is 25, because it will always tell the bigger one. So you see it says 25. Now if I reshape X the other way, so I want now it to be 4 by 25. So now there are many columns and just 4 rows. When I ask for size, it's 4 by 25, but when I ask for length, it will be 25 again. So it always returns the length of the maximal, of the kind of longest or the biggest dimension. So you could think of it as if it's maximum of size of X. That's how length works. If the matrix is square, of course, it doesn't matter which one it returns, because, so if I had 10 by 10, it would just say 10. So that's the length. So for instance, here, if I had matrix 2 by 3 by 4, three-dimensional, then the output of length would say 4. Okay, and then we go into command find. Now this one will be very important for you. Find or end or logical indexing. So the idea here is that quite often you may want to look for something specific inside your matrix. So for instance, a very good example is if you load data of some sales of something, and you know that there are some missing values in that data. So you would like to find where that missing data is. Or maybe the missing data can be just missing value completely, or maybe it has a wrong value, or maybe it has negative values even though they shouldn't be there. So if you have a data which has prices of an item, and those prices should never be negative, but you want to check in your code, are they really all non-negative, or maybe by any chance something is wrong in there, and then you may need to correct that, or maybe just remove those rows in your or columns in your data. But anyway, find is that command which locates what you want to find. And now how it works exactly. So if you just say find X, so for instance, again we had our matrix A. Okay, so if I just say find A, which sounds a bit silly, but let's start with that. Matlab will now list indices where my A matrix is non-zero. So for Matlab, as long as something is non-zero, it exists, so it can be found. Now, what does it mean? Now let's maybe take matrix B, but I will change something. So B was such that it had values from 11 to 18. Now I will change one of those values, or a couple of them, to zeros. So let's say 1, 2 becomes 0. I'm assigning value 0. Now you see the 12 disappeared, and there is 0. And maybe let's replace that one also. So it's 2 by 3, 2, 3, element 2, 3 should also become 0. So now my matrix B is like this. So what will happen when I and maybe even more, let's first look at a simpler case at just one vector. So I will now take from my matrix B just the first row to look at a simpler example. So if I now ask Matlab find V, what it will say is 1, 3, 4, because these are the locations in my vector of elements which are not equal to 0. Let's see. So you see, if something is 0, Matlab kind of tells it wasn't found. It thinks of it as like a logical logical false, so it means it shouldn't be considered, that particular element. So this is if you just put in directly just some vector or matrix. So now if I go back to my matrix B, remember I was telling you that in matrices, if some function doesn't support the functionality of 2 dimensions, Matlab visits a matrix in this way. So it visits the columns one by one until first one until the last row and then second. So if I have a matrix 2 by 4, it considers elements like this, that it is first element, second, third, fourth, fifth, sixth, seventh, and eighth. These are kind of the indices, how they are counted. So that's why when now I say find B, let's first have a look again how B was created. So it thinks of them like this. This is element 1, 2, 3, 4, 5, 6, 7, 8. So when I say find B, Matlab will not find the third element, which is this one, and sixth one, which is this, which means that the find command will say 1, 2, 4, 5, 7, 8. So you see 1, 2, third one is not on the list because it was a 0, 4, 5, 6 was a 0, 7 and 8. So that's how find works on matrices. But it also does support actually telling you the rows and columns, and all you have to do is ask for them explicitly. So how this happens now is that when I say find B, I have to point to it that I want the locations, so the rows and columns separate. So I will call those R and C. So now what happens is that it shows me respective information. Maybe it will be easier to look at it when I combine R and C together. So I'm creating a new array where R and C are the 2 columns arranged one next to another. So now you can see, I'll also bring back the B. Let's have a look. So it tells us that in first row, first column, there is a non-zero element, it's true. Second row, first column, it's true. Then there is second row, second column, this is true, so you see it omitted that one. And then first row, third column, this is true. And then first row, fourth column, second row, fourth. So those two and the 0 is omitted. So that's how you can get individually the row column combination of where your elements that you're looking for with some specified condition are located. So here in the slides are just a couple more examples. So once again, if you have some vector and you use find on it, Matlab will show you where are the non-zero elements. So locations, remember, it's the places, it's not the values anymore. But you could also put in the find a condition which now will generate a logical value. So now let's see what happens if in here I say we had a vector v, and I just ask Matlab v greater than 0, for instance. Or maybe not even, v greater than 11. So what happens is that it returns a logical array which is equally sized as my initial one, and it has answers true, false to my condition respectively to every element in my array. So I had 11, 0, 13, 14. Out of those, the ones greater than 11 are only 13 and 14, and these are the 2 trues which are here, and the other 2 elements are marked with false. So you see this kind of v greater than 11 produces a logical array of zeros and ones. And now if I say find v greater than 11, what will be the output? Well, it will be the answer to this in find terms. So it should point for us where are those which are non-zero. And that's place 3 and 4. So when I press enter, invalid expression. Oh yeah, sorry, I had that in the prompt. It is 3 and 4. So it really is pointing to where this condition is true. Where are elements which are satisfying this condition. Now if we go into higher dimension, so matrix B, once again, if I, for instance, want to ask where is B smaller than, say, 16, or let's combine it. And I'll try to combine, and at the same time I want B to be greater than 0. So the elements which satisfy this, so where this is true, is this one, these two, and this one. So when I press enter, I should have a logical matrix with values 1, 0, 0, 1, 1, 1, 0, 0, 0. So you see, 11 is within the range, 0 is not, 13, 14 are, 15 is, and the other ones are not. So once again, now if I tell Matlab find that condition which I had, let's do it this way. I recall it, and by pressing arrow up, and then let's add find. So now what I will get is, once again, if I don't point rows and columns separately, Matlab will say 1, 2, 5, 7, because looking at per column 1, 2, 3, 4, 5, 6, 7, 8, so it's 1, 2, 5, 7 which satisfy this condition. Yes, and here is one more example of what I have presented already. So in here, again, if we wanted to have the rows and columns, I will now actually, rows and columns, I will ask for them in this way, and again combine then the rows and columns together. So first row, first column was an element satisfying or falling within this range. Second row, first column, first row, third column, first row, fourth column. And then, so this is how you get locations, so the indices. But now, one step further from this, if now you would like to get out the values, so you'd like to verify and see instead of, because now it's a small matrix, so it's relatively convenient to actually check it by hand. But if you have much bigger matrix, you would still want to verify if you have maybe coded it correctly, so you'd like to see the values of those elements. So what you can do is now say that from matrix B, you would like those elements. So this was my find, which initially returned 1257. But now I want to tell Matlab, show me the values from matrix B, which are in those places. So you see, these are indices, these are locations, and I can use those locations to actually pick values from the matrix that I talked about. So now you see it brings out those values, 11, 15, 13, 14, and we can see indeed that they are less than 16, all of them, and greater than 0. And even more, this would have worked if we did not have find in here at all. So it is equally okay to ask for it like this, because now this, once again, this one returns a logical matrix which says true, false, respectively for every element. It checks the condition we wrote, It checks every element and says whether that particular element satisfies that condition or not. And once we have this kind of logical array, we can give that logical array as an index reference to pick elements from that matrix. Because what will happen is that Matlab will only pick those that are true. So if I run this one, I get the same result. And in reality, if you really don't need to see the location, sometimes you want to see that it's exactly that and that row where is a problem in your data maybe, and you want to go and check it manually. But if you don't need, if you just want to maybe see the values, or you want to modify something on the matrix, then you can use this logical indexing. This is called logical indexing. You can use it directly. And in reality, especially for bigger cases, this actually works just slightly faster than we find, because in here Matlab has to kind of do two steps or one step more. First, it anyway produces this logical matrix. Then it finds where are those indices, and then it picks elements of B with those indices. But in here, it just finds the logical answer, and then it picks elements where the answer is true.